All right, we're back. This is going to be page 8 of Notes 13. This is definitely not something that's a part of AP Calculus, but it's a way of solving some differential equations, first order linear differential equations, which means you have the first derivative to the first power. You have the original function to the first power. You have nothing else in terms of the function. So first order linear differential equations, and we can solve them using the integrating factor. We just have to make sure it's in the right form. So first thing we do is rewrite. So I'm divide through by x, get dy dx minus 2 over x times y equals dividing by x, so x cubed sine of x. Okay, so now I need to find the integrating factor. So it's going to be e to the integral of this thing. So our integrating factor is e to the integral of negative 2 over x dx, which, so usually when you solve these, you kind of play fast and loose with the absolute values. So I'm just going to say that's negative 2 natural log of x. I mean, it's absolute value of x, but we're also going to bring the 2 up as an exponent. So then we have the absolute value of x squared, which is just x squared. But it's really negative 2. So this is e to the natural log of x to the negative second. I'm going to write 1 over x squared. And then overall, e to the natural log of anything is just that thing. So this is our integrating factor. So we're going to multiply through by that. So 1 over x squared dy dx minus 2 over x cubed times y equals, so 1 over x, so x sine of x. All right. If you're doing this right, the left-hand side is always going to be the derivative of, so it's a product rule. So it's, first derivative of the second, second derivative of the first. So it's the derivative of 1 over x squared times y is equal to x sine of x. You can tell this side's going to be integration by parts. Happens all the time with these sorts of things. So when I integrate on this side, I'm just going to get 1 over x squared times y. And on this side, I'm going to get the integral of x sine of x dx. That's integration by parts. So I'll do it here, and then I'll move over there, I guess. I'll make u equal x dv is sine of x. So du is dx, and then v is going to be negative cosine of x. Okay, so where am I going? I'm going to go up, up and over. I'm going to write it down here, and then I'll just move it. So 1 over x squared y equals, so it's uv, so x, so negative x, cosine of x, uv, and then minus the integral of v du, so plus the integral of cosine of x dx. And now I'll pick this up and move it. That's an iPad problem. On paper, you can see everything, so not as big a deal, but I can't. So I need to integrate. 1 over x squared y equals negative x cosine of x. And then the integral of cosine is sine plus c. I feel like I'm getting this wrong again. This is the second time that I made this video. And the last time when I checked it, the answer looked nothing like this, I think. But I don't know. We'll check it. No reason to feel defeated yet, because it could be right. But last time I checked it, I think it didn't look anything like this. And if not, what is happening? All right, well, I'm going to use differential equation solver, which is, if you want to get it from the menus, menu 4, press up a couple times, you got to get to D. So y prime for me is, okay, x times y prime. I don't know that this works this way. Minus 2y equals x to the 4th times sine of x. Okay, independent variable is x, the dependent is y. I have no initial conditions, so just press enter. If you have a CX1 or an older cast, you have to type this in. You can still, there's still a menu, but it doesn't have that wizard thing. So I'm gonna press enter. Oh, this is, did I actually get it right last time and then like throw it away because the calculator, oh, I bet I typed it in wrong. I don't know. This, okay, but I did something wrong. So let me go back anyway. Careless error. It's like pretty early in the morning, and I'm making this because this is like a redemption video, which I'm not redeeming myself on. Look at this mistake that I've made. So it's a bad one. This c, when I multiply by x squared, doesn't absorb x squared. So I actually need to put c times x squared. And then if I had an initial condition, I would solve for it. Huge mistake. Do not make that mistake. Don't do what I just did. All right, let's see if the rest of these go better. So this one's already set up for us. So we need the integrating factor, which is going to be e to the integral of, so it's the coefficient of y, which is cotan. And what is the integral of cotan? Okay, why are you not? Sometimes when I'm trying to write it, it doesn't write. And that's great. Cotangent is cosine over sine. So think that through. You're integrating cosine over sine. So the integral of cosine over sine is the natural log of the absolute value, but I'm not going to put it of x, so sine of x. And then plus c, but I'm also not going to put that. You do a lot of like skipping and jumping when you're solving differential equations, which is why like differential equations are weird. Like a lot of the techniques of solving them seem to me to just be someone noticed. It's like, hey guys, look what I noticed. And then all of a sudden everybody's like, yep, that's how we're going to solve these from now on, which is kind of neat. 2i dx. So cotangent, let me see. Cotangent is cosine over sine. So when I multiply that by sine, which I'm multiplying through by, the signs cancel. So I actually just get cosine. I get cosine times y. And then sine times cosecant is just 1. Okay, so if we did this right, the left-hand side is going to be sine, the derivative of sine times y, which it is. I mean, look at it. 1. So integrating both sides, I'll get sine times y is the integral of dx. This is like, I don't know. This problem is not as hard as I don't want to say like hoping it would be, but like, am I doing it wrong? Because this is not the worst. So I get y equals x divided by sine, I'm going to say is x times cosecant. And then plus, remember, c cannot absorb it. So it's c over sine, but I'm going to write c times cosecant of x. I think it's important to like emphasize the multiplication symbol there because CSC is like, what is that? That's nothing. All right, back to the calculator. Let's check it. This one, if this one's right, that was smooth. DE solve. You always want to put in the original if you can. Y prime plus y times cotan of x equals cosecant of x, comma x, comma y. So x plus c divided by sine. Yes. What? All right, that one was a smoother path to the answer than I have become accustomed to in the last couple of videos. So let's see. Let's see one more. Maybe this one will, let's end on a bang one way or the other. Let's see. So first we got to get this in the form we want. So I'm going to divide dy dx plus, let's say 2x over x squared minus 1 times y equals x over x squared minus 1. All right, so we need an integrating factor, which again, it's e to the integral of the coefficient of y. So this, you get a lot of natural logs, definitely when you're doing like textbook problems. So this does end up e to the, this is perfect, natural log of its absolute value, but again, we're not doing that because we don't want to deal with it, essentially. we get this, x squared minus 1. So we're going to multiply through by x squared minus 1, which is going to have an amazing impact on this problem because of all the x squared minus 1 denominators. So we get x squared minus 1. What the heck? We're going to get back to the original. Should I have known that? I don't know, maybe. But anyway, we're going back to the original differential equation. Maybe this is, I could have done it perhaps by observation, but like, I don't think so. I mean, maybe somebody looked at that immediately, was like, yeah, I see it. I'm not that guy. So it's first, and then second. And then it's just x. Integrate both sides. On this side, we'll get x squared minus 1 times y. And then on this side, we'll get the integral of x dx, which like you could have just integrated, but probably better to show that. X squared minus 1 times y is 1/2 x squared plus c. Then we divide. I think I'm just going to write it as like 1/2 x squared plus c divided by x squared minus 1. Another option is x squared plus c over 2 times the quantity x squared minus 1, which like, I don't know, I think that the calculator might actually do that. Or maybe we got it entirely wrong. Let's find out. DE solve. So we had, the original was the quantity x squared minus 1 times y prime. I always do like a lot of multiplication signs on these because I'm not 100% sure, like I don't know what it wants and doesn't want, and you know, so avoid the problem. X is the independent, y is the dependent. So what is it done here? We got c over, there's no x squared like anywhere. Did it do division on my answer? Is that like a thing? But no, the 1/2 is off too. Delightful. It seems like I've gotten it perhaps wrong. Let me see. Denom. Answer. X squared. No, that's equivalent, right? Because 2 times c3 minus 1 is just like another c, and that would be like x squared plus c over. So why on earth? Why are those the same? Hold up. Let me do something here. Let's do x squared. I just like algebraically do not see why my answer is exactly the same. Expand. Ooh, do not expand that. That did not enlighten. I mean, these are equivalent, but why? Like, how is it? What is this? Oh, because a common denominator. I guess what I'm not seeing is like how the calculator broke that up. But you know what? I guess I don't really need to. I mean, it's an equivalent expression, and so yeah, we got it. Calculator answers on differential equation solver, mysteries. Mysterious little black box that does its thing, spits out an answer, and we're just thankful for it. Anyway, I think we got it right, despite how the calculator answer looks nothing like our answer, but it looks a little like our answer. All right, we're done. Woo! So I'm gonna end this video here. I'll be back in the next one. We'll be talking about something almost entirely different. Not entirely different. It's another differential equation, but it's a neat one. So anyway, I will see you there.